Am I out of time?
Well, thank you, Chris. Yes, you are, but thank you for that excellent presentation, and we're going to be moving on to our next presenter, Rebecca Cray. Thank you.
Hi, everyone. As Jennifer said, I'm Rebecca Cray, and I'm going to very quickly, in a lightning talk to you about establishing baselines and tracking trends, looking at 15 years of continuous water quality monitoring data from Estero Bay. So go ahead to the next slide. So just a little bit of background, not going to go into it too much. Estero Bay was established as an aquatic preserve in 1966 and later as an outstanding Florida waters. Both of these designations essentially indicate that the submerged lands and water quality are protected by the state to be maintained in an essentially natural condition and are not to degrade over time. And as such, that is to benefit the current and future generations who may use those resources. In part to assist with the management of our water quality and determine what those baseline conditions that we're seeking to achieve are. In 2004, Estero Bay Aquatic Preserve established a continuous water quality monitoring program. And the goals of that program, as I said, the first was to establish baseline water quality, to evaluate daily, seasonal, and long-term trends, and to quantify the effects of specific events. And essentially the basics of this program are that there are 3 sites in Estero Bay. You can see them generally located on the map. And at each of these stations, we deploy continuous data loggers that take readings every 15 minutes for 7 parameters. Those are temperature, salinity, specific conductivity, pH, dissolved oxygen, turbidity, and depth. So again, 3 sites, every 15 minutes, 24 hours a day, 7 days a week, 365 days a year. And so we can look at all of this data to see what some of the trends over the last 15 years have been. So next slide. So to analyze these long-term trends, I used monthly averages and ran seasonal man-Kendall tests for each site separately, and then for the average of all 3 sites. So that's what all means. In the top table, you can see more of the nitty-gritty, the p-values, the Kendall-Tau values. The bottom table, though, is a little bit more illustrative for our purposes and for the speed of this talk. And basically, it shows you the direction of any significant trends at each of the sites or at all of the sites, so bay-wide kind of. And for example, if you just look at EBO3, you can see that temperature increased over time, dissolved oxygen increased over time, but salinity decreased over time. Next slide. I can also kind of show these things graphically. So this first graph is looking at the water temperature monthly across all of the sites. And so each of those little open circles is a monthly average. And then the lines are showing 2 different types of slope. The red is a Sen-Thiel slope, which is generally used when looking at man-Kendall tests. And then the blue is your standard linear regression slope. And obviously the 2 slopes are very different. If you used the Sen-Thiel slope to kind of extrapolate change in temperature over time, you'd get 1 degree Celsius increase every 16 months. But if you take the linear regression one, it's 1 degree Celsius increase every 10 years. So again, obviously very different, but the trend is in the same direction. All right, so then the next slide, similar type graph, same setup, 2 lines, but both of these are declining. We're talking about salinity, bay-wide, again, averaged across all 3 sites. And over time, you can see the decline. Next slide. Again, same type of graph, all sites included. You can see that there's an increase in dissolved oxygen over time. And this is dissolved oxygen concentration, not percentage. All right, next slide. And at one specific site, EBO1, which if you remember the map was kind of our northwesternmost site, we had a statistically significant increase in turbidity. If you look at the linear regression slope, it equates to about 1 turbidity unit increase every 6.5 years. Go ahead to the next slide. So from there, I'm going to move to a different type of graph. So as we could see, there were trends in several parameters over time. I want to look a little more in depth at the 3 that were significant across all of the, across bay-wide, I guess, when you averaged all sites together. Those were temperature, salinity, and dissolved oxygen. So first we'll look at temperature. And this graph is a little different. Basically, the graph shows daily averages from each site, averaged across all 3 sites, and then averaged for each 5-year period of time. And then plotted January 1st on the left to December 31st on the right edge of the graph. The dark green line shows the first 5 years, 05 through 09, the blue line, the middle 5, 2010 through 2014, and the yellow line, the most recent 5 years, 2015 through 2019. And from this graph, it's a little harder to see than some of the following ones, but especially if you compare the yellow line to the green line, so most recent to most distant, waters seem to warm earlier, maintain higher temperatures longer. The low dip in the winter doesn't seem to last as long. There are some differences that you can kind of see between the 3 lines. Next slide. Again, similar type of graph. The lines all mean the same thing, except we're looking at salinity. And as you can see in this graph, the lines are a little more distinct from each other, less overlap between them. And you can especially see that the most recent 5 years, the yellow line, seems to show lower salinities, especially during the wet season. Next slide. And then finally, it seems that dissolved oxygen concentration, especially in, again, the wet season, the middle portion of the year, that seems to be increasing in the most recent 5-year period. It's higher than either of the previous 2 5-year periods of time. And basically, these 3 graphs all opened up to me more the question of, are we experiencing a shift in baseline? When we're talking in a management context and trying to figure out what conditions we're supposed to be maintaining or managing for, what is that for our particular purposes? Generally speaking, when I have a new year's worth of data, I compare it to the average of all previous years. But is that actually the most appropriate? Should I only compare to the first 5, the first 10 years? Essentially, how do you go about establishing baseline conditions, especially when you don't have data that goes back as far as when the bay was designated as an aquatic preserve or even as an OFW? So this was originally planned as a poster, and I had actually been really looking forward to conversing with other people who work with long-term data sets, water quality or otherwise, to talk about how they tackle the question of establishing baselines. So after this is over, if you want to shoot me an email or give me a call and talk about how you tackle that, I would love to engage with you, so please feel free to do so. And then I'll wrap up. Basically, next slide is just my citations. And the slide after that, I do have to acknowledge this program has been going on for 15 years. I've been with it, thankfully, for the last 4.5 or 5. But obviously, there were a lot of other people involved now and in the past. So I want to acknowledge all the staff, volunteers, regional colleagues who have managed and assisted with this program since it began. You can't keep a long-term data set going without a whole bunch of people being committed to doing so. So thank you to all of them, and thank you to all of you for bearing with my rapid speak, and I will now happily take your questions.
Great, thank you, Rebecca. We have about 5 minutes for Q&A, so we'll be going back to menti.com. For those of you who are joining us late, just use the code 639808 at the top of the screen and enter any questions for Rebecca now.
Okay.
Rebecca,
yeah,
take it away.
Okay, thanks. So the first question is, is one I've thought a lot about and I don't have a great answer for. Yes, generally speaking, temperature and dissolved oxygen are inversely correlated. So why are both going up, especially in the summer months? I honestly can't tell you. I have, I guess, a few thoughts. I don't know if any of it has to do with increased, I guess, sources of dissolved oxygen. Is our seagrass, you know, producing more oxygen or doing better? Same thing with any, you know, algae or other things that create the dissolved oxygen. Are there improvements there that are kind of counteracting the temperature? Does salinity somehow factor in here with a lowered salinity threshold? I honestly don't have a great answer. I would love to know if any other people see this sort of thing. So yeah, if you can answer that one for me, I'd love to know, but I don't have a good answer. A lot of it is about dissolved oxygen. Okay, so I'm gonna skip over those for a sec because again, I don't know. Let's see, why lower salinity? So that's a good question. And I haven't had the opportunity yet to look into that more, but I would like to. Lee County has a great daily rainfall data set that I'd like to look at to see if it just so happens that we're getting more rain and therefore greater freshwater inflow through that. The other possibility is that that comes to my mind anyway, is that as development on land increases and water flows off the land more quickly during rain events and the rainy season, that water isn't absorbed as much as maybe it used to be and runs more quickly into the bay and therefore dilutes the salinity more. But I don't have the data to support either of those options. It could be natural, it could be anthropogenic, it could be a combination of the two. I don't know exactly. Any changes in water transparency? So that would, I'm assuming you mean water clarity with that question. And again, the only site that showed a turbidity change over time was that northwesternmost site, EBO1. The others didn't have a statistically significant trend in that parameter. So, I don't know, it didn't decrease or increase over the period, I guess bay-wide if you look at it across all three. So I'm not sure if that could, be a factor, and it's just not a detectable trend yet as far as our data goes. Yeah, I don't know. When did monitoring for this area begin? If you mean this specific data set, like I said, it started in 2004. I looked at the period of 05 through 2019 just so I had full years, since I think a couple of the sites started in July of 04, one of them in November. So I wanted to make sure it was a consistent period for all three sites. Other water quality monitoring, like grab sample monitoring programs, began in the 90s as well. So I could look at grab sample, like, monthly data sets for that to see if there's a comparison. Yeah, so can I incorporate older monitoring data? It's something I'm going to try and look at to see if I look at trends in monthly data sets where it's just you go out and take a reading once during an entire month period, and you aren't getting that like consistent 15-minute sort of data. I want to see if the trends between the two types of monitoring kind of line up. And if so, then in theory, yeah, you can kind of back extrapolate, so to speak, to look at, what those readings may have been in previous years, but I haven't done that sort of analysis yet. And then,
Well, with that, Rebecca, I think we're out of time. Thank you so much for your excellent presentation. And again, everyone, feel free